next comes the interface. What happens when we talk about the solid liquid gas interface? Now, this is a very complicated thing, and this is what people are trying to study and master at different levels, I would say, in different universities. The first one is single phase interface, solid to solid interaction. I just gave you a good example like WBM, water bound macadam. That is why the name is water bound macadam. Clear? Design of filters. Any other example which comes to your mind? In soils, let us say you are adding another type of soil, amendment of soil, alright, soil replacement. If you want to decrease the plasticity index of the material, what you are going to do? You are going to reduce the liquid limit by adding some silt fraction or coarse grained fraction into fine grained soils. Clear? So, if I am playing only with the particles and if I am creating a different state of the material, this could be a solid to solid interaction. So, reduction of plasticity index is another good example of solid solid interaction. It is not of much interest, I would say, because this part is well understood. Now, look at the liquid liquid interaction. Can you cite some examples of liquid liquid interaction which are occurring in nature? So, this is one of the examples where the leachates in the liquid form is interacting with the groundwater. Any other example which we might have cited by this time? So, there is another example, seawater intrusion. So, seawater, because of its density, higher density than the fresh water, has a tendency to diffuse into the aquifers. Nice. Any other example? More contemporary, you might be watching in news.
Oil and water.
Where it happens?
Oil spills.
Excellent. So, this is another interesting topic, oil slicks we call them in the ocean, slick or oil spills. Oil spillage is used normally on the ground, oil slicks are normally on the water bodies. So, that is a very good example you are talking about, liquid liquid interaction where the oil gets creates an interface with the sea water. Any other example? Liquid liquid. Any types of fluids, liquids coming across or interacting with each other with different densities, different viscosity.
Sewage when enter rivers, it could be
sewage disposal system. Yes, you are right, but sewage is a multi-phase system, please remember. Another good example is you start your day with that. You have a cup of tea and in that you add few drops of honey, is it not? There is another interesting interaction, liquid liquid interaction. So, you can think of several other situations. Now, these type of situations have to be modeled. Gas gas, sorry, where do you come across gas gas interaction?
So, the fumes from factories are expelled into.
Correct, very nice. So, fumes which are coming out of the stacks of the factories, they are interacting with the atmosphere. Excellent example, gas gas. Any other example of gas gas? Landfill. You have different type of gases interacting with each other. You can't control that I am going to have only methane gas, though the objective is to decompose the material in such a manner that I should get controlled emission of methane gas. But truly speaking, you have all sorts of gases which are also interacting and forming a consortium of gases in the landfill. So, this is another good example where people will like to work, particularly environmental geomechanics guys. So, these are the micro details of the MSW disposal. I hope you can realize now, only disposing and talking about MSW is a big issue which many people are already thinking. These are the minor details on which technology should work. Alright. Now, let us talk about the two phase interface. So, two phase interfaces would be, let us say, solid liquid. One good example would be spillage of anything which is occurring on the soil mass and then percolation occurs. Another good example would be WBM itself, though we consider this as a single phase, but truly speaking this is a two phase interface. Why? WBM without water is not going to function properly, the compaction is not possible. So, water has its role when you are talking about WBM, clear. So, good example of solid liquid interaction would be you have particle sizes of different sizes, and the moment you add a little bit of water they get compacted easily, compaction curve. Unless you add water you can't compact the material. So, this is a good example of solid liquid interaction. All sorts of spillage, you were talking about the slicks earlier, now we are talking about the spillage. So, there is a tanker which is carrying some petroleum or chemicals and some accident happens and this tanker spills everything on the ground. This becomes a point source of contamination. In conventional geomechanics, you have talked about point loading, you remember, line loading, uniformly distributed load, circular loading, square loading, triangular loading, different patterns of the loading. Now, what I have given you an example is the example of the spillage which is creating a point source of migration of contaminants into the subsurface, because as compared to the infinite domain which we are talking about of the soil mass, that size of the tanker is going to be extremely small. So, this can be considered as a as a point source of leakage. Pipelines which are carrying crude oil and somebody punctures them, just to tap, unauthorized stealing of the oil. So, after they have filled up their buckets, what happens? The rest of the thing is simply percolating into the ground. So, this also becomes a point source of contamination. What about solid gas interaction? MSW will be a very good example of a two phase system where the solids are interacting with the gases, municipal solid waste. Decomposition of the waste is taking place, all sorts of gases are developing, getting created, and these gases interact with the solid phase of the material also. Anything else apart from this solid gas interaction which you might think of? Decomposition of organic matter in the soils because of UV rays, alright, and this decomposition causes gases, methane gas, and these gases get trapped in the sediments, soils. Hydrates, which we talked about, is a wonderful example of solid gas interface. In fact, we will be putting it in the three phase system, that will be more complicated. Gas liquid, you can think of the methane which is coming out of the hydrates interacts with the sea water, would be one example of gas liquid interaction. Then we have to talk about multi-phase interface, and this is solid liquid gas system, clear. So, what normally we do is in environmental geomechanics we try to create interfaces. See, you have already dealt with these things in the disguise of a capillary action when you were studying in the soils. You remember your capillary model? So, there is a water which is available in a pot and then you put a capillary tube, and then what happens? This water rises in the capillary tube, and then we said the sides of the capillary tube are equivalent to the grains of the soil, clear. So, you have capillary tube, you have water column, you have air interface, contractile surface normally we talk about. So, you have air water interface, and then sides are glass or soil particles. This is the third interface. So, we have done it, but we have ignored it there by taking surface tension. But in most of the realistic situations, what you have to do is you have to do justice with the material, and you have to talk about the interaction which is occurring between the solids, liquids and gases. Okay. So, let us move ahead with the type of energy fields. The basic hypothesis is that a particle would react differently in different energy field, and what we are interested in is we are trying to understand the response of the particle when it is exposed to a energy field. So, this becomes particle energy field theory. So, we talked about the individual particles, we talked about the particle systems, and now we are talking about the different types of energy fields. Okay, third component of PEF theory. I hope you have studied these concepts of body forces and the surface forces, grain structure of soils, if you remember. So, we have single grain soils, we have fine grain soils, coarse grain soils, and so on. So, when we say that surface force and the body forces are gravity forces, surface forces could be electromagnetic or whatever, these depend upon the mechanical energy field. Conventional geomechanics deals with flow of water because of hydraulic gradient, height of 2 points in the tube, and then finding out what is the elevation head, what is the pressure head, what is the velocity head, all are mechanical attributes. So, when we talk about the mechanical attributes, we use the concepts of kinetic energy or potential energy. Is this part clear? So, most of the systems which you are dealing with in conventional geomechanics, be it consolidation, you take the sample of soil, you load it from the top, and then what happens? The static energy or the potential energy is getting converted into kinetic energy. We will discuss these points. The sample consolidates. What has happened? The particles are traversing, they are moving with some velocity towards each other. Initial particle was in static state, you applied pressure on this was the static stress, and this static stress got converted into kinetic energy. Water starts coming out because of the pore pressure generation, kinetic phenomena. So, this is what is mostly used in geotechnical engineering, and it does not include the influence of environmental stresses. And just let me remind you, environmental stresses are thermal stresses, chemical stresses, magnetic stresses, electrical stresses, biostresses, radiation stresses, and so on, and the combination of these. Now, this whole theory, that is mechanical energy field concept, is based on the density and volume. So, when you are taking certain amount of soil with certain volume and you compact it, clear? Compaction theory. The density changes. Why? Because the particles, because of compaction, are coming close to each other. So, from the static state where the potential energy was controlling the system, now the kinetic processes come into it. Because of compaction, particles crush also. Is this correct? Because if the crushing strength is less as compared to the compaction energy, the particle would get crushed. If you are doing a compaction of a granular material, there will be a lot of sound coming because of the compaction of the particles, friction. Sometimes there could be heat which is getting generated because of this friction also. Sometimes there could be, particles could be charged, and if you bring them close to each other, there could be a generation of electromagnetic field also. Are you getting this point? So, truly speaking, when we talk about even a simple phenomena like compaction or consolidation, the way we are handling this in conventional geomechanics is not correct. Why? Because truly speaking, we are not really using the conservation of the energy, which is a situation or which is a very critical phenomena to estimate the initial and final states of the material and how much energy gets stored in the system or how much energy comes out of the system. Clear? So, truly speaking, if you really want to recreate the compaction theory or consolidation theory, what you should be doing? You should be measuring all these sorts of energies which are getting generated in the process. Is this okay? The sound, the heat, there could be spark also because of the chemical processes, and whatever. So, if I go for a new classification system of the soils, whether they are compactable or not, whether they are they will consolidate or not. What I should be doing? I should be modifying all my tools which I am using to quantify these mechanisms. So, suppose soils are thermally active. You understand what are thermally active soils? Calcareous soils, or the soils which have a lot of sulfates in them. And the moment you add water to them, what is going to happen? The sulfates and carbonates would react with water, and the whole process could be endothermic. Sometimes it could be exothermic also. That means the heat might produce, or sometimes the system might get cooled also. Alright. So, I am sure now you are realizing that even a simple phenomena like seepage through soil mass is not so simple the way it has been treated. And why it has been treated so simply? Because you have ignored the attributes of contaminants and the soils completely. You never bothered about the chemistry of the soil. You never bothered about the chemistry of the percolants. You agree with this? So, active percolant like sulfuric acid, when it comes in contact with the soils which have a lot of calcium in it, what is going to happen? When sulfuric acid reacts with calcium, it is going to be a exothermic reaction. Are you getting this point? So, that is the need of the hour. So, why we are talking about energy field theory? Because we are trying to develop something which is more holistic as compared to the one which we have been using until now. Is this part clear? So, I have cited several examples. Now, you just think and apply your mind to create situations where the energy conservation concept can be utilized in geomechanics to reframe the theories. Load deformation characteristics. The best way would be if I plot stress strain relationship, and you might have done in your 10+2 physics, if I integrate over the surface of this graph the area which is confined by this sigma versus epsilon relationship, this is nothing but the work done. Clear? So, this is another way of looking at the concepts. So, total energy of the mass change is becoming useful. What I will have to do? All the consolidation tests and compaction tests I should be doing in a calorimeter now, because then only I can measure what is the heat of liberation, what is the heat of reaction, what is the heat of sublimation. Are you getting this point? Because when interaction starts, you do not have much control. It depends upon the attributes of the geomaterial and attributes of the percolant. And in nature, any sort of this thing might happen. Hope you are getting the answer to the question which I asked you some time back, that despite doing the best possible sampling, despite doing the best possible testing, and despite using the best possible softwares, why our systems are failing?
Whenever we design, we always want to go to like reality according to our learning of the subject. Probably there might be some lag in that process.
Correct. So, are you realizing the lags? So, these are the key things which have been not included in this discussion of the classical geomechanics. Yes.
So whenever we develop theory, like in engineering, we always have some overlying assumptions and approximations. Like as long as this thermal energy or sound and light energy are not as much that influence my consolidation process, or that I can still, like I'm of the view like I can apply, because going into this is also not easy, sir.
Very good. So, I hope you are ignoring a fact that the marine clays would have a substantial amount of calcium in them, which you have completely ignored. And listen, look at the counter logic. So, I am yet to see a marine deposit which would not have organic matter, which would not have calcium content in it. And what is the constitution of seawater? Chlorides, sulfates. So, they are all the time interacting with that. I hope now you are convinced. So, the simple answer is that for the sake of convenience, or maybe to begin with the subject in 1930s and 1940s, people started working on these concepts with lot of limitations and assumptions. But unfortunately, in 2020 also people are following the same thing and they are not ready to change. When you are observing that the requirements to understand the material are much more, and much more critical, because you are dealing with typical projects right now. Is this okay?
So while doing the hydrometer analysis, we actually add hydrogen peroxide and heat it, right? So with it, so what we're doing, like exothermic reaction takes place in like soils like marine clay and black cotton soil. So the readings that we get are actually not representative, right?
The material itself is not representative of what it used to be. So, for the sake of convenience and to cover up your ignorance, you are simply saying just treat this and get rid of organic matter, and I will deal only with the particulate system, which is not correct. You are finding out the response of the material which is totally different than the one which was existing in nature. That itself is a gross injustice. That means we have to stop these practices and think of something which are better and more comprehensive.
What would that?
Yeah, so you will learn all that. You have to be patient. First thing is to realize that whatever I have been doing is incomplete or incorrect. Then the second stage is how to correct it, how to complement this. You understand? So, these are the sequence of learning. It is interesting, I think. The logic is good. So, unfortunately, what did you do? You brought the sample from the field, you said to get rid of organic content, put it in the oven. You killed most of the material there itself. Then you washed it with sulfuric acid, hydrochloric acid, then H2O2, then you boiled it also. Alright. So, no way this material is same as the one which was existing in Bay of Bengal, on which you wanted to create a structure. That itself is a big deviation. Then second thing is you added something more to this to deflocculate it. Clear? In nature, nobody is going to add deflocculant. So, you have to deal with the sediments which are lying in the nature. You wanted to get the response of that system, not the one which is created by you as per your convenience. So, I am sure you must have realized that when we talk about the particulate systems like soils, the energy is associated with the orientation of the particles, flocculent structure, dispersed structure. So, flocculent structure, if I tamp it, what happens? It gets converted into dispersed. Why? No, you are basically supplying more energy to order. So, let us discuss a bit about this thing. Another thing is that now you are realizing that there are gases which are present in the voids, which we have ignored completely in the conventional geomechanics. We never bothered about the pore gases. We never bothered about the dissolution process of the gases into the pore fluids. So, when you do load stress strain relationship, what happens? When you are applying pressure on the soil system, the chances are that the gas might be getting dissolved into the pore fluid. So, that itself is a sort of a reduction in the volume, clear, and these type of volumetric reductions we are not taking into account in realistic situation. So, we have to talk about these issues. I am sure you can realize that the mechanical energy field oriented theories cannot take into account these effects, because you have only two components, either mechanical energy field position head, kinetic energy component velocity head, and the pressure head, Bernoulli's equation, which is used to solve most of the problems in geomechanics. Similarly, we do not talk about the effects of the elastic strains of the grains. We always assume them to be incompressible. But now I think with our discussion for at least 8 lectures, you must have realized that there are ample opportunities for the soil grains to get deteriorated or to get upgraded also. The bacteria does tricks, the chemicals might be doing this trick. So, longer the interaction between the chemicals and the soils, what is going to happen? Mineralogical alteration. We discussed today morning, is it not? So, that means when even quartz comes in contact with bases, hydroxides at elevated temperature for a pretty long time, there is an alteration in the material property. We will discuss this quite in details, and I use the word zeolites to define this. that means the material itself is getting changed and you are still assuming the compressibility of the particle to be incompressible. We do not talk about characteristics of the double layer, and double layer formation is the electromagnetic process. You remember double layer concept? So, you have the particle of clay when it is dipped in the water, you have cations which are present in the system, the concentration is very high close to the particle and it decreases as you go away. So, this composition or this system where the clay particle is having adsorbed water and the cationing is known as a double layer. So, mechanical energy field cannot take into account the effect of double layers. Now, when we talk about the long term interaction, whatever I have discussed until now is going to become more critical than the immediate testing. In conventional geomechanics, we have done mostly the tests which were short lived, short duration tests, clear. Even if you do a CD test, consolidated drain test, normally it is done for 3 weeks, 2 weeks maximum. Hydraulic conductivity test you do for how many days? 7 days maximum. Consolidation test might go for 3 weeks at most, clear, but these are not long term. So, long term would be in let us say decades, hundreds of years of the interaction. So, when we talk about the long term interaction, then I am sure you will realize that the mechanical stress component or the mechanical energy component is going to be extremely less as compared to the other stresses. You remember the analogy that most of the geotechnical structures are sitting in or maybe directly exposed to the environment, embankments, dams, roads, foundations, though they are covered, but still they are in touch with the groundwater continuously, clear. So, thermal stresses are going to control the stability of the embankments much more as compared to the mechanical stresses. Are you getting this point now? Is this part clear? So, these type of analogies we will now create to see what is the response of thermal energy field, which could be solar, which could be from the forging unit, which could be from a buried cable which is emitting lot of heat, which could be from a rocket launching pad, which could be from any other industrial activity, disposal of waste at a elevated temperature, clear. Electrical energy field, I hope you understand, magnetic energy field, radiation energy field and so on. So, when we talk about the long term interaction, these energy fields become important, we have to include them in our analysis.